We didn't ask why. We asked why not. We look, we seek, we find, we uncover. We are the optimistic architects of tomorrow. At ARM, our partners have come to trust us, to craft everything from the core of what drives it to something that makes lives simply better. Simply smarter. Smarter homes, smarter phones, smarter cars, smarter communities, smarter cities, smarter world. The billions of things connecting us, bringing us closer together, making us healthier, making us happier. And this is only the beginning. What comes next, and next, and next, is ours to blueprint. Success is measured through our partners' freedom to dream, to build and to create the seemingly impossible, making the ordinary incredible, thanks to what is at its very essence. The possibilities are limitless. The outcomes are endless. At ARM, we can go anywhere, anywhere our intellect and our imagination take us, because anything, everything, and all things are possible.
今天的记者会当中，我们特别邀请到 ARM 副总裁暨运算产品事业部总经理 Nandan Nampally， 以及 ARM 副总裁院士暨多媒体处理器事业部总经理 Jem Davis 来到现场。This morning we have the pleasure of having Nandan Nampally, Vice President and General Manager of Compute Product Group at ARM, as well as Jem Davis, Vice President, General Manager and Fellow of the Media Processing Group at ARM。我们首先邀请 Nandan 上台为各位分享。Let's first welcome Nandan to the stage.
So, Sao An, hopefully that works. Good morning. It's great to have all of you here. On behalf of Jem, myself, and all of ARM, I'd like to welcome you all to our event, and also thank you because for a lot of you, it's a national holiday in your respective countries. So thank you very much. But after all, it's Computex. Interesting things happen. And hopefully, this will be as exciting to you as it is for us. Now, a year ago, on this very same stage, I think Renee and myself were here. We were launching the Cortex A73 CPU and the Mali G71 GPU. And you can see how those two processors have raised the game for smartphones and for larger screen compute in devices that you see this year. Now, this year, we're even more excited because what we're sharing with you is really targeted at accelerating the paradigm shift that we need for an increasingly intelligent world. Now, if you look at the trends are saying we have smarter devices everywhere, from the sensor to the server. So if you look at the tiniest IoT device, there's more sensing capability, more compute capability in it. You look at edge nodes, which are getting smarter, network, and all the way to the data center. And what this requires is not just a single strain of compute. It needs obviously more fit for purpose, more efficient purpose compute that is targeted at those various applications. You need not just CPU, you need GPU, you need specialized acceleration, and a very heterogeneous context. That basically means you can't have just general compute, you need what we term as total compute. And the ARM platform is exactly what is there for it. We have not just a type of CPU, we have a wide range of portfolio CPUs, starting from Cortex M0 and the increasingly secure Cortex M23 for the tiniest sensor, all the way to the Cortex A72 and what you'll be hearing about today for networking, data center, and cloud. We have GPUs that'll fit your build for edge compute devices all the way to HPC class capability. We have IP for vision, we have IP for connectivity, overall, ARM and its ecosystem is capable of delivering that total compute. And then you consider, what do you use for your primary compute platform? Today, over 70% of the world's population uses ARM-based platforms for their primary compute, whether they be through consumer devices or more likely to mobile devices. Now, 70% of the world's population is a pretty sizing number. But this is only the start, because if you look at the pervasiveness of the ARM architecture, the readiness of the ARM ecosystem, the availability of software and expertise for ARM, you can see where we're going with this. Earlier this year, we announced that ARM partners had shipped over 100 billion devices from the start since 1991. Now, let's think about that for a moment. 100 billion, by scientific estimate, is more than the number of humans that have lived on this planet since the beginning of time. That's quite a sizable number. But what's even more interesting about numbers is the acceleration that you see in it. The first 50 billion chips that were based on ARM devices took 22 years to actually deliver. The next 50 just took 4 years. And if you look at last year, ARM partners shipped over 16 billion chips with ARM processors in them, and over 1 billion of those had Mali GPUs. That's quite a pretty picture there. But what's more interesting is that in the next 5 years, we expect the ARM partnership will ship 100 billion more units, so doubling what was shipped since 1991 in just 5 years. And what's driving it is that the nature of compute is changing. As we see intelligence going towards the node, we talked about smartness, but now we're converting that into intelligence. If you look at that, AI will have to come much closer to the edge, which means there is more compute and more devices that need to be supported for it. As these chips and as these services become part of our daily lives, these need to be even more safer and autonomous, because they are beginning to control effectively what we do or help us in what we do. When we start thinking about mixed reality, augmenting what you see today with greater visuals but inferences and capabilities built in, that throws a lot more compute requirement in there. And all of this has to be hyper efficient. So the same old, one size fits all is not going to work. And as you start seeing most of these things moving closer to the edge, you will need more compute that drives more volume, more chips. Now let's dig a little bit deeper. This concept of moving intelligence to the edge is what we term distributed intelligence. Now, an example of this is the announcement that you might have seen or heard on the Google Lens. Now, the Google Lens is designed to convert the camera on your phone, rather than a passive capture of imagination or video, but into more intelligent ways. So you take a picture of a router box and the password on it. Lens may be able to tell you or infer that you want to connect to the Wi-Fi and take the steps necessary to actually make that happen. So this can only be done as you move more compute, more intelligence to the edge. And when you do that, it's in the palm of your hand. As you start moving more of these intelligent capabilities to your devices, it's useful because now security is localized. So the devices that generate your data, your habits, can be closer to you and encrypted whenever you transmit, so you have better control on what you own. And these are getting increasingly more graphical capabilities. So not only do you have 4K video, high dynamic range capabilities, but these are now overlaid on intelligent compute, intelligent inferences into the system. So in order to create all this, it sounds like a lot of compute that needs to happen, right? But the important thing here is it's not going to be designed by just having discrete graphics, discrete CPU. It has to be pulled together on SoCs, and again, these SoCs are not one size fits all. So the first thing you need is probably more performance than you have today. That's, I guess, a simple answer. And it would need more single-threaded performance, more GPU bandwidth performance. But it's not just instantaneous performance you need. Because the level of compute is not just instantaneous, you need it to be sustained, and you need it to be efficient because more often than not, you're doing it in form factors that have thermal and power constraints. As I said earlier, it's again not just about just CPU and GPU. You need more IP that is specialized for compute pulling it together. It's heterogeneous. From the ground up, when you look at design, these have to be designed for functional safety. Now that involves everything from requirements capture to delivery, failure recovery, failure safety, but also there's additional compute required to support that. And then of course, when you think about it, underneath all that, you need security and privacy. All of this is what you need to deliver this distributed intelligence to scale. So let's talk about how we started this. In March, we announced the ARM Dynamic Platform. So I'll say this again, it's not Dynamic IQ, it's dynamic, just in case anybody was wondering, okay? Now, from the ground up, it is designed for AI. Now, you may say, what does that mean? Well, what we mean by that is that we are designing it for that heterogeneous compute that pulls together all aspects that are needed for intelligent computation. Naturally, that means you need CPU performance to go up. It means that you can make it low latency and connected to other accelerations that are needed for this. And then you actually look at what do the CPUs themselves need to do. And we're trying to improve every component to be more capable of handling AI-capable workloads. Okay? We talked about how in the next 3 to 5 years, just the CPUs themselves within Dynamic would enable you to get a 50 times acceleration in AI-type workloads, let's say generic matrix multiplies, or convolutional filtering, etc. In fact, over there, you'll see some of that already showing up through the ARM compute libraries, but also you'll see more coming through the processors we're going to talk about today. So that kind of brings me to the big announcement we have today. The first 2 processors designed for the dynamic platform are the Cortex A75 and the Cortex A55 processors. So the Cortex A75 really raises the bar on performance, substantially higher than we have today, while maintaining the power profiles. The Cortex A55, while raising performance, really grows the efficiency for the broader proliferation of the dynamic-based platforms in here. So let's dig a little bit deeper. When we talk about the Cortex A75, it's a substantial uplift in performance. If you consider the premium mobile platforms of today, I think your Cortex A73 is running 2.4 gigahertz, etc. By the time we get to the Cortex A75, 10 nanometer technology, probably at 3 gigahertz, you'll see over a 50% improvement in just the raw compute integer performance. Floating point performance will be higher, and specialized workloads, especially for AI, as I mentioned, will be even higher. Now, all of this is done while maintaining the power profile fitting into the smartphone power budget. And that is important because if you can stick to that smartphone power budget and deliver that much more performance, when you start getting into notebook form factors, you are substantially higher for fanless devices, etc. Now the features, and I'll get into that in a second, are also such that it's not just for mobile and not just for edge compute, but really scales all the way to cloud compute. So the Cortex A75, performance-wise, is capable of supporting large screen form factors while maintaining the smartphone power budget. It has additional instructions, especially dot product FP16 type instructions that'll push specialized AI workloads. But the ARM v8.2 architecture gives it a number of additional benefits. You have data poisoning and capabilities that help reliability, atomic operations that'll make communication of lots of processors within a cluster much better, and effectively, beyond that, specialized virtualization support, which makes it much, much better for enterprise applications, where you can deliver substantially better TCO, or total cost of ownership, than the incumbent solutions. So it's very attractive for networking infrastructure. It's very attractive for data center. Now, all those capabilities also mean that reliability-wise, robustness-wise, it also becomes a very good starting platform for safety-critical functions such as autonomous driving. Now, along with dynamic and the Cortex A75 and the product that we announced last year, the Cortex R52, you can generate or design an ASIL D-capable autonomous platform or automotive platform. And this gets interesting not just for cars, or driverless cars, but a lot more around industrial and home automation. Now, if you go to the other end, you have the Cortex A55, which is the little for the big core. And remember that the Cortex A55, while being a little for the big core, is also the bulwark or the basis for mainstream mobile and entry-level mobile on its own. So if you consider the Cortex A53, which has been very popular today in the mainstream mobile applications, mobile phones, a lot of them are shipping in 28 nanometer. By the time you see Cortex A55 come out, it will have translated to 16 nanometer. A combination of the inherent benefits of Cortex A55 along with 16 nanometer technology will deliver about 2.5 times the efficiency for these applications. So think about that. That really changes the amount of performance in the same footprint that you can get, allows you to do much more dense compute. And that means you can have sustained multi-core performance for a lot of these applications. That'll help you with not just entry-level phones and mainstream phones, but edge-level compute, IoT gateways, single-board computers, and a lot more. So where does it all lead us, right? So we talked about intelligence at the edge. So moving more dense, more capable compute, which again has AI acceleration capability to the edge, really gives you a big step in moving it in that direction. With the kind of efficiency we're talking about, you have everyday, all-day life for even the smallest devices, even with larger screen factors. And then you're beginning to see how these small footprint devices can start changing how you do home automation, factory automation, and more. All of this because, just like the A75, on the basis of dynamic technology, you can certify it in ASIL D, or functional safety critical aspects. So, if we put it all together into a dynamic cluster, you have a lot more capabilities showing up. You could have multiple configurations of the Cortex A75 and the A55, still architecturally compatible within the same cluster. That makes your big little solutions substantially better because the latency of inter-processor communication has been substantially reduced. And what that also means is, in each processor doing a lot more in a lot less time, and the communication being even a lot lesser, you are effectively doing the same task in a lot less time. Overall efficiency grows substantially. And if you consider these options, you have a very wide range developing because it's all in the same cluster. You have the high end, which is notebook or laptop ready with 4 big and 4 little processors. You start getting into the mid-range, and this is where it starts getting very interesting because it allows you to swap in today's 8-core Cortex A53 type solutions. You can swap in a big core, or maybe 2. That gives you a substantial bump in instantaneous performance that the Cortex A75 could provide, while providing you the capacity and bandwidth that the other 6 or 7 little cores could help you with. And then at the entry level, a single, a dual, or a quad core configuration really changes how much compute or how much compute density you can have at the edge. So now we're talking about what we've done with redefining multi-core. We've talked about the Cortex A75 and A55 processors, more performance, greater efficiency, specialized instructions. We've talked about the dynamic platform that allows you to connect not just CPU, but specialized acceleration into this, but also coherently connects to the GPU and visual processing. Now, obviously, this picture would be incomplete if we didn't have a GPU to go with it to expand the capability. And to talk about that in a lot more detail, I'd like to invite Jem Davies, VP and General Manager of the Media Processing Group.
Thank you, Nandan. So we've heard about ARM's new Cortex CPU cores, the new dynamic technology, and the markets these will lead into. But now I'd like to focus mainly on the mobile market and how these two cores, along with ARM's new premium Mali GPU from our new mobile suite, will fit in. Firstly, however, let's look at some of the market trends and user experiences that are driving the development of our new high-performance GPU. We have machine learning. Machine learning techniques are increasing across all mass market applications, and ML, we know, places high demand on compute capabilities in the mobile world. For reasons of power and bandwidth and latency, which affects the user experience, it needs to be run locally, on device, wherever possible. We have virtual reality, where ARM provides optimized technologies for an impressive and immersive VR experience, which contributes to our leadership in mobile VR. I'll talk about market shares in a while. And we also have high-fidelity mobile gaming. This genre of games is challenging the console-based games for the quality of the graphics and are growing at a faster rate across the industry than the normal games. For example, in China, total revenue growth for these high-fidelity mobile games grew twice as fast as the gaming industry average. And why is this happening? Because the underlying mobile technology we now have is performant enough to enable such complex graphics and deliver stunning visual experiences across all these three areas. But first, I'd just like to say a word about the success of ARM's Mali multimedia IP. I'm very pleased to say that in 2016, the Mali GPU was once again the world's #1 shipping GPU. In fact, in 2016, ARM's partners shipped over 1 billion chips containing Mali GPUs. That's a historic milestone. We're not quite up there with my CPU brethren yet, but it's a pretty good number, and we're very proud of that. Mali GPU's market share is also continuing to grow. We have about 50% market share in mobile VR, and about 50% of the smartphones as well, and those are both continuing to increase. And yes, we're proud of that, but of course we don't congratulate ourselves for too long. We can never stand still. We continue to develop market-leading IP to enable the newest and most challenging use cases. And so, I'd like to introduce the Mali G72, our new premier GPU. The Mali G72 builds on the success of Mali G71 and adds further improvements to the Bifrost architecture, which they are both based upon. It brings over 1.4 times the performance over its predecessor, and this makes it even more suited to the demands of these latest complex use cases that we're talking about, whilst dramatically reducing power consumption. And as well as enabling the ultimate in mobile gaming and VR experiences, Mali G72 takes the already very impressive machine learning capabilities of its predecessor and the Bifrost architecture and launches them really into the next dimension with specific optimizations to enable those use cases. So we've talked about some of the use cases for the Mali G72 GPU. Now let's look at those improvements we've made to the design over the previous generation and look at them in a bit more detail. So for us, it's all about efficiency. 25% more graphics energy efficiency so that those complex use cases can be supported for longer without overheating, stressing your system or killing your battery. Machine learning, absolutely on everybody's radar at the moment. Well, we've specifically optimized the Mali G72 to improve machine learning energy efficiency by 17%. And finally, size and scalability. So our partners are now choosing to build ever more capable, bigger configurations of our GPUs, right up to 32 core configurations. And so a 20% area reduction is extremely welcomed by them to enable more performance in a smaller silicon budget, which brings capabilities down to lower cost devices and making them ubiquitous across all of the edge devices we're talking about, not just mobile. So let's look a little more detail then at that machine learning optimizations. As I said, the Bifrost GPUs were already designed for machine learning. We saw this one coming. The take-up of machine learning in the last few years, though, has been really significant. So what we've done in the Mali G72 is to take this even further. We've made specific optimizations in the ALU design, the data path in the ALU, and also cache improvements predominantly around reducing energy consumption of the data movements through machine learning, predominantly matrix arithmetic. The combination of these improvements allows Mali G72 to reach that 17% greater energy efficiency levels than the Mali G71, which was pretty good already, running GEM matrix arithmetic for machine learning. And this makes Mali G72 ARM's most efficient machine learning GPU. And now moving on to mobile VR. Given the cutting-edge VR technologies, Mali's always been at the heart of mobile VR, with about 50% market share in the mobile VR devices. We have a number of capabilities which I'll talk about. We have mobile multi-view, and Mali G72's efficiency improvements here are perfect VR, making the efficiency effectively twice what you get out of any particular rendering, as the scene is always rendered twice, so we get twice the value out of it. Improvements to the tile buffering design inside the GPU means that Mali G72 performs MSAA, which is predominantly used on very high-end content. It makes it do that much quicker. Of course, efficient use of bandwidth is absolutely key in mobile platforms, and using ASTC allows game providers to use much higher quality textures to get a better visual experience while saving precious bandwidth. And as I'm sure you all know, bandwidth is power. And Mali G72 is, of course, designed with ASTC, fully designed in the hardware. I'll talk about another technique we're using, something called foveated rendering. This is where we fully render all the pixels in the area of the eye's focus, but spending less effort on the pixels outside that specific focus area. This leads to further efficiency improvements, and we've taken that particular use case and optimized it in Mali G72. Our new mobile VR demo, Circuit VR, which was launched at GDC earlier this year, uses foveated rendering in combination with mobile multi-view, and it decreased the GPU workload by about 20% compared to the previous version, and that translates to more battery life and less heat. And you'll be able to see the demo. It's being demonstrated over there by our colleagues over there. You'll be able to see that later. Moving on further to other aspects of high-fidelity mobile gaming, what's going on here is really that the GPU is having to do a lot more work. Game developers are using more and more special effects and advanced rendering techniques to improve the realism of the images that are created to make you feel more immersed inside that game. And the thermal budget is what traditionally limits performance in premium mobile systems. That thermal limit is, just how much power can you use before things start to be throttled back. And a significant proportion of that heat is caused by data movement. So we've concentrated very hard on reducing data movement through the system, optimizing it where possible, and reducing the power consumption of that data movement. The use of advanced rendering techniques like multiple render targets, or MRT, is typically employed in very high-end fidelity games from consoles and PCs, and that incurs a significant cost in terms of data movement. And data movement is bandwidth consumption, and bandwidth consumption is power. So I'm sure you've all been concentrating, and Mali, as you know, is a tile-based architecture. And we use a clever technique which avoids the massive bandwidth overhead of classical MRT, and we call that pixel local storage, or PLS. And ARM worked alongside Digital Legends to optimize their high-fidelity after-pulse game and make use of PLS. Going from Mali G71 to Mali G72, MRT saves you 42% of write bandwidth. And then turning on PLS on that system gives you another 45% bandwidth reduction as well, giving you a total bandwidth saving of over 68%, as you can see from this graph. And of course, with that bandwidth reduction comes a power reduction. So we've seen how Mali G72 enables visually stunning high-fidelity gaming and enables all these new use cases such as mobile VR and machine learning. If we add Mali to the new CPUs and other ARM technologies, you now have a brand new 2017 premium mobile IP system. And so bringing it all together then, as always with ARM, it's not just about the leading IP, the CPUs and the GPUs. We've built a complete suite of IP, whether it's crypto IP with Trust Zone CryptoCell 712, or whether it's connecting all of that compute IP with our interconnect, or POPs, physical IP libraries and implementation guides that enable our partners to build systems to performance points faster and get them to market faster. There's more. We are introducing a complete set of reference data for a mobile subsystem, the nattily titled SGM 775. And that includes everything from the SoC architecture through to detailed pre-silicon analysis and models and software and more and more and more. And this is all available for free to ARM's partners. So what are the cores bring us? What have we done here today? Cortex A75, of course, delivering groundbreaking performance whilst maintaining strong efficiency. That enables more AI compute on device, which enables you to bring more trust to that device, more privacy to your AI applications, and improves the user experience. Cortex A55, of course, enabling new levels of efficiency and much higher performance for a broad range of devices, for smarter, more efficient devices. Mali G72, our latest premium GPU, bringing also new levels of performance for gaming, for VR, and for machine learning. And put this all together, the combination of CPUs, dynamic IQ technology, GPUs in a big little technology system, it's really changing the game. It's doubling the performance for the next hundreds of millions of users. And the real point underlying all of this is that ARM is changing to address how compute is changing around us every day and how devices are becoming smarter all the time. So, as you can see, we're focused on complete solutions providing compute for distributed intelligence. We're accelerating performance with dynamic, with new CPU cores, Cortex A75 and Cortex A55. We're introducing the new Mali G72 for high-fidelity gaming and all other forms of visual computing. We're raising the bar on our mobile compute performance, and all within the mobile power envelope. Don't forget that mobile power envelope doesn't get any bigger. It never gets any bigger. We're working inside that same constraint all the time. And we're paving the way for a faster and more secure AI capability for hundreds of millions of user devices. Thank you very much. Cheers.
Thank you, Jem and Nandan. And now, ladies and gentlemen, a recap of the key messages today.谢谢各位，接下来我们进行媒体 Q&A 的时间，我们欢迎 Nandan 还有 Jem 再一次来到台前。And now I would like to welcome Jem and also Nandan to the stage for the media Q&A session. 待会各位媒体朋友提问的时候，请您举手，简单介绍自己的大名跟单位，我们会将麦克风递上。Also, please identify yourself, your name and affiliation. Our staff will hand you a microphone.
Don't be shy.
如果要发问的话，就请举手，我们将麦克风递上。Yes, in the back.
你好，我是那个拓扑的分析师。那我想请教一下，就是 Nathan， 就是刚刚有提到那个他有提到Cortex A75是针对10奈米的部分去做一个演示，然后 A55是针对16奈米。那对于 IC 设计客户而言，他们如果推到客户这边的话，他们会建议，就是ARM会建议什么样的制程会比较适合客户？就是在 Big Little 这样的一个A75跟55合在一起的时候，什么样的制程会比较合适？谢谢。
So this question is directed at Nandan, and I am an analyst at TRI, and I would like to ask a question about, you talked about Cortex A75 and also A55 using different nanometers in terms of the production. So I would like to ask you, in terms of big little cores, what kind of production process would you recommend to the IC design partners?
That's a good question. Like every processor we design or piece of IP, it's portable across process technology nodes, right? So as I mentioned, we do think for a lot of the mainstream type implementations, you could actually do very well with an A75 and an A55, even in 16 nanometer. So we talked about 10 nanometer, which is more of the premium, larger configurations. But 16 nanometer would be equally attractive for a lot of the mainstream applications. And then you could go even kind of with lower process technology nodes if you wanted to, but I think the sweet spot is probably between 20 and 10, somewhere in that range.
Thank you, Nandan. Any other questions? We have a question in the back.
你好，我想请问一下，那个新产品 A75是否适用在 server 的领域？就是说有没有 server 的 chip？ 然后另外是目前有没有什么合作伙伴已经应用这新的产品？
So the question is the Cortex A75 suitable as server chips? And also, are there any partners already for Cortex A75 and also A55, or the new products?
Okay, again, very good questions. We traditionally announce licensees at this event. However, we also respect the licensees' ability to make their own announcements. So we have been working with a number of licensees, both for the A75 and the A55. And again, those licensees are taking them into very different markets, and you'll hear about them as they bring their products closer to them. Now, the question around A75 for server, certainly if you look at where the market is, even today's Cortex A72-based platforms are being touted into some of the distributed compute for a cloud. Naturally, A75 being that much more performance, plus with having some of the architectural enhancements for reliability, for better virtualization performance, better atomic operations, makes it that much more attractive for the server market.
Thank you, Nandan. 还有其他的问题吗? Any other questions from the floor? Yes, also in the back.
你好，我想请问一下，就是可以再说明一下那个 Mali G72 如何在 GPU 上面加速机器学习以及人工智慧的发展。另外 ，Mali G72 现在已经有 lead partner， 就是合作伙伴了吗？
So this question is about Mali G72. How does it, in terms of the GPU, accelerate AI as well as machine learning? And also, do you have any lead partners at the moment?
So my answer to the lead partner question is very similar, unfortunately, to Nandan's. When we were breaking into the market, then announcements of new lead partners were very newsworthy and very groundbreaking. Of course, now we're basically licensing to everybody. It's not so interesting. So our partners are now looking to control their own news announcements more closely. So we're not announcing anything at this stage. How we're doing it on machine learning is predominantly through analysis of the actual workloads. So you have to invest in a big effort in analyzing the particular workloads, working out what it's doing to every single part of your GPU, the data paths, the ALUs, where is the energy being spent. And as I said, for most of these devices, it's the thermal budget that is the limit. So we concentrated on reducing the energy used for those machine learning workloads, which are matrix arithmetic, both of integers and of floating point. We changed some of the data path arrangements and also tuned cache configurations and layouts to reduce energy for that.
Thank you, Jem. And a gentleman in the back.
Hi, Brian Ma from IDC. Nandan, you made a few references to quote-unquote laptop-ready performance, which in my mind can't help but bring to mind Windows 10 on Snapdragon. Now, I'm sure you don't want to speculate, but I guess I'm curious to hear your thoughts on, do you anticipate Microsoft opening that up to a broader range of ARM-based processors? And even if you don't want to go down that path, I guess I'm curious to understand, when you say laptop-ready performance, how do you envision that kind of end product in the end? Are you thinking something like a clamshell type of device, maybe running Android rather than Windows 10? I guess I'm curious to hear you elaborate a little bit more on that. Thanks.
Okay, Brian, so you were right on the first answer. I'm not going to speculate. On the second one, I think in general, right, if you look at what ARM IP and processors have done, and our partners, in fact, have done, is change the way you interface with the device. I mean, smartphones were very interesting, and it's not just a keyboard and a screen. It is how you interact with it that changes, which has also led to some of the clamshells now developing those interfaces alongside keyboards, etc. So I do think that the innovation on how you interface with large screen devices will continue, but certainly clamshells is a way to do that. Clamshells with touchscreens or convertibles or two-in-ones or whatever the flavor of the month is in terms of titles is very much a part of it. But also it really opens it up for, you know, other, it's not just Windows but others, right? So Chromebook type devices, there's a lot more interest in different countries to do their own. So really what we're trying to enable is the expectation of the kind of performance that you wanted from a clamshell device being available, but also being done where you can actually make it thinner, fanless, and capable of delivering you that.
Thank you, Nandan. We also have a question in the back.
I'm Trevor Huang from Microelectronics. And during the presentation, I saw there is an accelerator in your platform. And I'm wondering if that's a hardwired accelerator or sort of circuitry like a processor which can support kind of programmability. Thank you.
Okay, I'll take that. You? And then we can do that. So the first thing I'll say is that accelerator is not on our roadmap, right? So it is not, what we're saying is that the ARM partnership is used to doing specialized solutions. What Dynamic affords them is the ability to tightly couple their own specialized accelerators to a standard interface in a very low latency way to connect to the CPU. Having said that, we do have IP for vision, and in fact, Jem will probably take the ball from here and talk about other things that might be possible with it.
So yeah, the ARM partnership, of course, is so broad now that you can't you cannot specify how people will do things. People will do things in a multiple ways. Some people are looking to connect DSPs, some people are connecting other programmable processors, other people are connecting fixed function accelerators. With our acquisition of Apical last year, we now have the imaging and vision group within ARM who are clearly viewing this space with great interest, and we're looking to make best use of the technologies that enable most efficient joined up total computing across the variety of solutions. So if we look at, for example, machine learning, you might have some of that code running on CPU, you might have some of that code running on GPU, you might have some of that being done in special purpose accelerators. And one of the things we're trying to do to ease the way through for the ARM partnership is the introduction of the ARM Compute Library, which is used as the foundation of a library enabling neural network code to be distributed across a bunch of devices. As I say, we're not trying to enforce in any way decisions on the ARM partnership. They have ideas of their own anyway. We couldn't do it if we wanted to. But we're trying to make it easier for people to connect multiple devices to produce end devices designed for applications we haven't yet considered. Right. We don't have to have all the smart ideas.
Right, and that's just to wrap up, I think the whole point is innovation is not our domain only. It is, in fact, using the broader innovation across the ecosystem to deliver very different devices.
Thank you. I see a question, I think, in maybe the second row.
Hi, Hirogoto, Peace Watch. Hi, Nanda. I believe you're going to provide POP process optimization pack of your CPU IP. Could you tell us for which process technology are you going to provide your POP of your A75 and A55?
That's a very good question, Goto-san. So today, effectively, you will see more about this in the next few weeks, about the POP IP that we are providing for A75 and A55. So I will probably hold off that announcement till they can make it. But like we do, we traditionally try to provide for the key nodes that matter to our customers the POP IP for it, which is again geared towards giving you the mandated performance and time to market. And also that doesn't mean that the announcements are going to stop, right? So we will have more and more POP IP as they are driven by customer demand.
Thank you. Any other questions? 还有其他的问题吗？ All right, if not, I would like to ask Nandan and also Jem to remain in your seats for a photograph. 我们最后请 Nandan 跟 Jem 一起合影留念。我们也请我们的摄影师到台前来帮我们捕捉这一次2017年 Computex 的画面。
Thank you.
So can I have
No,
you
you've got to
both
sit down.
Oh,
boy.
sit, continue.
seated? And we'll take one standing up.
Okay.
今天非常感谢各位媒体朋友莅临 ARM 2017年 Computex 的展前记者会。我们的活动到这边告一个段落。不过欢迎大家参观 ARM 在 demo 区的产品跟技术，抢先体验一下。也非常感谢各位今天的莅临。另外，我们在现场也备有一系列 ARM 在 Computex 展期的活动列表，欢迎各位媒体朋友参观与会。也提醒各位，在离开的时候，请将耳机还给媒体报道台的工作人员。如果有任何问题的话，也请洽询我们现场的工作人员。非常感谢各位。So once again, thank you for joining us at the 2017 Computex ARM Press Conference. Please be sure to check out the demo area to experience ARM's latest technology before you leave. Also, ARM will have a series of events during Computex, so participate in these events if your time allows. You're more than welcome. Also, please remember to return your interpretation headsets on your way out. Thank you very much and have a nice day.